Imagine looking up at the night sky. Thousands of stars scattered across the darkness. Beautiful, silent, peaceful.
But hidden behind that calm view, deep in the glowing heart of the Milky Way, there is something so powerful that space itself bends around it. A place where gravity becomes almost impossible to understand. A place where time slows down. A place where light can orbit, but never escape.
At the center of our galaxy sits Sagittarius A star, also called SGR A star, the supermassive black hole that anchors the Milky Way. It is located roughly 26,000 to 27,000 light-years away from Earth, buried behind clouds of gas, dust, and stars, and yet astronomers have found a way to see its shadow.
Not with ordinary light, not with a normal telescope, but with a planet-sized network of radio telescopes called the Event Horizon Telescope. In 2022, humanity saw it for the first time, a glowing ring of superheated gas wrapped around a dark center, the shadow of our galaxy's black hole.
And what scientists discovered was both terrifying and beautiful. Because Sagittarius A star is not just an object in space, it is the gravitational heart of the Milky Way.
And everything around us, our sun, our solar system, our planet, and every star in the night sky is part of a galaxy shaped by the invisible power of this cosmic monster.
But here is the most shocking part. Sagittarius A star is massive enough to contain about 4 million suns. Yet, compared to other supermassive black holes, it is strangely quiet. It is not tearing apart huge amounts of matter every second. It is not blasting enormous jets across space like some active galaxies. It sits there, silent, almost sleeping, but not dead. Because every now and then, Sagittarius A star wakes up. Astronomers have detected powerful X-ray flares coming from the region around it. These bursts suggest that material near the black hole can suddenly heat up, accelerate, and release intense radiation before disappearing into the darkness.
For decades, scientists could not directly see Sagittarius A star. The center of the Milky Way is hidden by thick cosmic dust, making it impossible to observe clearly with ordinary visible light. So astronomers had to prove the black hole was there in another way. They watched the stars. Near the center of the galaxy, stars move at incredible speeds. Some of them orbit an invisible point in space with extreme precision. One of the most famous of these stars is called S2, also known as S02. This star swings around the galactic center in a long, stretched orbit. At its closest approach, it passes incredibly near Sagittarius A star, moving at thousands of kilometers per second. The only thing that could make a star move like that is an enormous amount of mass packed into a tiny region. Not a cluster of ordinary stars, not gas, not dust, a black hole. This discovery helped prove that a supermassive black hole sits at the center of the Milky Way, and the work of astronomers Andrea Ghez and Reinhard Genzel was recognized with the 2020 Nobel Prize in Physics. But confirming its existence was only the beginning. Scientists wanted something even harder. They wanted an image.
The problem was almost impossible. Sagittarius A is enormous in mass, but from Earth, its apparent size in the sky is incredibly tiny. Trying to image it is like trying to see an orange on the surface of the moon. No single telescope on Earth could do it.
So scientists connected radio observatories across the planet, from Antarctica to Chile, from Hawaii to Europe, creating a virtual telescope as large as Earth itself. This was the Event Horizon Telescope.
And in 2022, after years of data collection, processing, and analysis, The EHT revealed the first direct image of Sagittarius A star. What appeared was not the black hole itself. A black hole emits no light.
Instead, the image showed glowing plasma, superheated gas moving at extreme speeds around the black hole. At the center was darkness, the black hole's shadow.
This shadow is caused by gravity so intense that light is bent, trapped, and swallowed. The bright ring was uneven because the gas around the black hole is moving rapidly, and Einstein's theory of general relativity predicts that light from this region will be distorted in extreme ways.
This image was more than a picture. It was evidence that Einstein's equations still work in one of the most extreme environments in the universe. But then, scientists looked deeper. In 2024, the Event Horizon Telescope released a new view of Sagittarius A star in polarized light. This revealed something extraordinary: strong, organized magnetic fields spiraling around the edge of the black hole. These magnetic fields looked surprisingly similar to those observed around M87 star, the massive black hole in the galaxy Messier 87. That similarity shocked astronomers.
M87 is billions of times the mass of the Sun. Sagittarius A star is only about 4 million solar masses. They exist in very different galaxies, and yet, near the edge of the black hole, nature seems to follow the same deep rules.
This suggests that magnetic fields may be a universal feature of black holes. They may control how matter falls in. They may help shape powerful jets. They may even explain why some black holes become cosmic engines while others remain quiet. Sagittarius A star may appear calm today, but evidence suggests it has not always been this way. Astronomers have found signs of past activity near the galactic center. Light echoes and X-ray reflections suggest that Sagittarius A star may have produced stronger outbursts in the past.
In cosmic terms, our black hole may simply be resting between meals. Because a black hole does not constantly consume everything around it. Matter must get very close before it can fall in. Most stars and planets in the galaxy are perfectly safe because they orbit far away. Even our Sun does not orbit Sagittarius A star directly, like Earth orbits the Sun. Instead, our entire solar system travels around the Milky Way's center, taking about 225 to 250 million years to complete one galactic orbit.
The black hole is not a vacuum cleaner. It is more like a gravitational anchor. Its influence helps us understand the structure of the galactic center, the behavior of stars in extreme gravity, and the history of the Milky Way itself.
But one question remains. Could Sagittarius A star ever become dangerous? For Earth, the answer is no. It is far too distant. At 26,000 light-years away, Sagittarius A star cannot pull in our solar system, and its current activity is not a threat to life on Earth.
But scientifically, it is one of the most important objects in the universe, because it is close enough for us to study in detail. Other galaxies have supermassive black holes too, but they are much farther away.
Sagittarius A gives scientists a natural laboratory for testing gravity, plasma physics, magnetic fields, and the behavior of matter near the event horizon. The event horizon is the boundary of no return. Cross it, and nothing can escape. Not matter, not radiation, not even light.
But the strange thing is, we do not need to cross the event horizon to learn from it. Everything happening just outside that boundary leaves clues. The way gas glows, the way light bends, the way stars orbit, the way magnetic fields twist. Every signal carries information from the edge of the impossible.
And the future may reveal even more. The Event Horizon Telescope is improving. More telescopes, better resolution, and new observing methods could one day allow scientists to create moving images of Sagittarius A star.
Not just a still picture, a movie. A real-time view of gas swirling around the Milky Way's central black hole. Imagine watching matter race around the edge of a black hole, moving close to the speed of light, distorted by gravity, stretched by magnetism, and glowing before vanishing forever. That would be one of the greatest scientific achievements in human history. And Sagittarius A star is the perfect target. It is close, it is mysterious, it is quiet, but not silent. And it is sitting at the center of our cosmic home. For most of human history, people looked at the Milky Way and saw a river of stars. Ancient civilizations gave it myths, legends, and spiritual meaning. But modern science has revealed something even more astonishing. That river of stars flows around a hidden darkness, a black hole, a gravitational monster, a place where our understanding of physics is pushed to its limits. Sagittarius A star reminds us that the universe is not only made of light, it is also shaped by darkness. And sometimes, to understand the galaxy we live in, we have to study the things we cannot see directly. Because at the center of the Milky Way, 26,000 light-years away, there is a shadow surrounded by fire. A silent giant holding millions of suns in its gravitational grip. And every new image, every flare, every star orbit, every magnetic field line brings us closer to answering one of the greatest questions in science. What really happens at the edge of a black hole? And maybe, someday, Sagittarius A star will help us uncover the deepest secrets of space, time, and gravity itself. Until then, the monster at the center of our galaxy remains there, quiet, powerful, waiting in the dark. If you found this journey into the heart of the Milky Way fascinating, make sure to subscribe to Infinite Science for more cinematic stories about space, black holes, planets, and the mysteries of the universe. Because the deeper we look into space, the more we discover that reality is stranger, darker, and more beautiful than we ever imagined.